Hey, fourth grade, how are you? I hope you had a great Memorial weekend. Had a good time with family. That's super. Uh, right now, I'm talking to you the week of the end of Memorial weekend, but that week. And this video is for Monday, June 2nd. Okay, so we are continuing on in Unit 7. Okay, I believe today, if I remember right, this is the end of Module 1. Okay, and the next time I see you, we'll begin Module 2. I'm really hoping in the next few videos we can finish all of Unit 7. You know, it might be a lot of work, but remember, you always have extra time to work on it, okay? So let's look at, from what Bridges wanted me to show you this week, is the bar model for equivalent fractions, okay? So let's start with our bar is, think of a bar of chocolate for an example. And remember, when you're comparing fractions, you have to use the same size figure. You can't use a small Jets pizza compared to a large Jets pizza. It's got to be the same size. So even though my drawing isn't perfect, I tried to make these rectangles exactly the same. So we have 2 out of 3 here, 2/3, and we got 4 out of 6 for 4/6. But as you see, I tried to draw a line. It's not perfect. But yes, 2/3 and 4/6 are equivalent. Okay? So in the Bridges book, obviously they have a computer doing it, so they're going to be perfect. Okay? So you can see these are equivalent. But it's also, let's say if this was 1/3, you could see that 1/3 is quite a bit less than 4/6. If this happened to be 1/3 comparing 4/6. So that's the bar model. And then they also wanted me to show you that when you're making an equivalent fraction, you can take the original fraction, 2/3, you can multiply it by any number as long as you multiply the numerator and the denominator by the same number. You can't go, hey, I'm going to multiply this by 2 and this by 3 and get an equivalent fraction. Nope, that won't work. So notice I went 2/3 times, I did 2 times 2 is 4, 3 times 2 is 6. Okay? Well, you can also do that with 3/3. 2 times 3 is 6, 3 times 3 is 9. And yes, all of these fractions are equivalent. Okay? Then I jumped down and I did a bigger one, 6/6. So 2 times 6 is 12, 3 times 6 is 18, and yes, 12/18 is still 2/3 if you reduced it, okay? So Bridges had me do some more of these, but I thought, no, I'm going to switch it up and show you that you can actually divide to make equivalent fractions too. And this comes in handy when we ask you to simplify fractions into their lowest terms, okay? Like 25 out of 100, is 1/4 out of $1, so 1/4, okay? So that's lowest terms, 1/4, from 25/100ths to 1/4, okay? So as I go down here, I got to get on my knees. So if we have 15 25ths, I'm thinking, well, what goes into 15 and 25? Oh, 5 does. So if you divide the numerator by 5, you get 3. If you divide the denominator by 5, you get 5. And look at that, 3/5. What about if it's 12 20ths? And you're like, hey, what number goes into 12 and also into 20? And yes, 2, you're thinking, yeah, well, 2 does too. But I'm trying to get to 3/5. Okay, so let me think here. If I did 12 20ths divided by, a 2 on both sides, 2/2, I get 6/10. And yes, as you see down here, 6/10 is actually 3/5, but you have to divide by 2 again. So that's why I divided by 4. I wanted to go from 12 20ths all the way down to 3/5. So I got the greatest common factor between 12 and 20, which is 4, and I divided by that. And that gave me 3/5, and that's lowest terms. So then we have 9/15. What's the greatest factor of 9 and 15 that are the same, so I can divide by that and get lowest terms? Well, it's 3. Because the factors of 9 are 1, 3, and 9. The factors of 15 are 1, 3, 5, and 15. The greatest one that's the same is 3. So if you divide by 3/3, you get 3/5. And finally, 6/10 divided by 2 on the top and bottom, you also get 3/5. Okay? So this is a way, I wanted to show you this because this is how we figure out how to make a fraction that's not in lowest terms into lowest terms by dividing by the greatest common factor of both of these numbers. Okay? And if you're not thinking, let me just show you real quick. I wasn't going to do this, but now I'm just going to do it. Okay? Factors of 15 are 1, 3, 5, and 15. Remember that? Factors of 25 are 1, 5 times 5. So only write it once, and then 25. Well, look at the greatest common factor of both groups is 5. That's why I divided by 5. And that gave me lowest terms. Okay? So, up here, thinking back to my days in 4th grade, I want to show you what little Billy Bauer did way back in 1970, okay, when I was in 4th grade. So when we had unlike denominator fractions, and we had to compare them, and we had to find common denominator, okay? So there's a couple ways of doing it. First, let me explain. Yes, you can always do 3 times 5. You could do 4 times 10. You could do 5 times 8. That's the easy way. But you can also do, let's see, this one actually works better for what I'm trying to get across to you. So we could do 40 for a common denominator because we know 4 goes into 40, 10 goes into 40 because 4 times 10 is 40. So they both work. But what if we don't want our fractions that big? Can you think of another number that, 4 and 10 will both go into that's smaller than 40? Let's see. Well, the way I always did it, first off, is let's go way back to the beginning. I'm looking at, will 4 go into 10? Nope. Let's say 4 did go into 10. Can I change this and not freak everybody out for a second? 5 and 10? Well, 5 goes into 10, so we're going to use 10. Because I know 5 goes into 10, and obviously 10 goes into 10. Okay? So we're going to use 10. But what about if it's a 4? Okay? Well, 4 won't go into 10. So I've always, since 4th grade, I've gone to, you go to the bigger number and you go to the next multiple. Because 4 goes into 12, but you sure know that 10 doesn't. So let's go, what's the multiple after 10? 20. 4 won't go into 10, but 4 will go into 20. And 10 must go into 20 because it's a multiple of 10. So yes. See, and so instead of using 40, we can use a little bit smaller denominator of 20, okay? How do we get the top number? Well, remember what we talked about. Whatever you do to the top, whatever you do to the bottom, you have to do to the top, okay? So how does 4 become 20 times 5? Well, to keep these equivalent, remember I showed you before, you got to multiply by the same number, okay? And what happened to 10 and 20? Times 2, times 2. Now you can compare, okay? So obviously 3/4 is greater than 7/10 by 1/20. By 1/20 greater, okay? So let's go back to this one. 3 won't go into 5, so I'm going to take 5 and make it 10. Will 3 go into 10? No. So the next multiple of 5 is 15. Will 3 go into 15? Absolutely. Because 3 times 5 is 15. Okay? So what happens to 3 to 15? It went times 5. Do the same to the top. 2 times 5. 5 times 3 became 15. 3 times 3 is 9. And there, once again, you can see that 2/3 is 1/15 greater than 3/5. Now this one down here happens to work out here where 5 won't go into 8. And if we do multiples of 8, we can do 16, no. Okay, 24, no. 32, 5 won't go into 32. But both of them will go into 40. So that ended up working out. 5 times 8 is 40. So 5 times 8 is 40. 3 times 8 is 24. 8 times 5 is 40. 5 times 5 is 25. Now, when they get to this point, you can just look at them. The denominators are the same. So you just look at the numerator to tell you, hey, 25 is greater than 24. So that means 5/8 is greater than 3/5. Okay? Now, before I move on, I wanted to show you real quick. My 4th grade teacher also, we did it like this because right now we can, because we have a common denominator, we can add it if we wanted and get 10 plus 9 is 19 and the 15 stays the same, 19/15 if we wanted to add these fractions. And it also works for subtraction as long as the bigger fraction's on top, okay? So it works out that 10 times 9 is 1, 10 minus 9 is 1, and the 15 stays the same. So my 4th grade teacher, we always lined up our fractions like this to change the denominator, because even if we're just comparing, get rid of that subtraction symbol. If we're just looking at them and comparing, yeah, you can just look at them and see 10/15 is greater than 9/15. But it also works when you set it up like this. It's real easy to add and subtract. Okay, I just wanted to show you that. Okay, so when you're comparing fractions, there's 4 things I want you to think about, okay? Number 1, how close are, let's just go with 2 fractions. I know we could compare 3 or 4 and put them in order from least to greatest, but let's just start with 2, the basic, okay? How close are they to a half? If 1 is greater than a half and 1 is less, then you already know the greater fraction. So remember, 2/4 is half. So 3/4 is greater than half, 3 out of 4. If you go to 2/6, you know half of 6 is 3. This is only 2. So we have one here that's greater than 1/2, and we have one that's less than 1/2. So it's obvious which one's greater, okay?
Hey, you don't even have to do any work, really.
Nope.
Cool, just some logic there.
Yep.
All right.
So number 2, what if they're close to 1? So let's look at it. So how close are they to 1 whole? The one that's closer to 1 whole is greater, obviously, okay? So here's 9 out of 10 versus 5 out of 8, okay? Now, if you think of 10 pieces, yeah, they're smaller than 8s. They're a little bit smaller than 8s, but look how we're only 1/10 away from a full whole, and this is 5/8, okay? So 9/10 is larger.
Yeah, you could look at that and go, 9/10 of a pizza is more than 5/8. Like if I eat 9/10, yeah, that makes sense.
Well, and you can even go back to the first one. Half of 10 is 5, half of 8 is 4, and this is only one more past half, and this is way past half.
Yeah.
So a couple ways to look for it.
Good logic there.
We can also use a common denominator. If we're looking at 2/3 and 7/9, just change them to 9ths, okay? Now we got 6/9 versus 7/9. That's obvious, okay? Common denominator. My 4th grade teacher, we didn't even use anything else. That's what we used. Common denominator was my thing in 4th grade. So number 4 is, this one's kind of cool. If the numerators are the same, think about the size of the denominator, okay? So forget this for a second, concentrate on this. So if we have 3/7 versus 3/10, okay? And I put here, remember, 1/7 is greater than 1/10. Remember that? because this is 10. If we're talking about the same size round pizzas, okay, and this is 7 pieces and this is 10 pieces, these pieces are going to be smaller. So 1/7 of a pizza is bigger than 1/10. So if you have 3/7 of something versus 3/10 of something, okay, yes, the smaller denominator is the bigger fraction, okay? If the numerators are the same, the smaller denominator is the bigger fraction, okay? Now, lastly, a lot of my 4th graders already have been told you can cross multiply to check for greater than or less than on 2 fractions, okay? So if you don't know, let me show you how this works. So I'll just start here. 4 times 2 is 8. It's called cross multiply, by the way. 7 times 1 is 7. Okay, so we have 8 versus 7. 8 is bigger than 7. So 2/7 is greater than 1/4. That's called cross multiply. If you ever get stuck and you're looking for which fraction's bigger and you're comparing just 2 fractions, you can use that. But you really, if you have a bunch of if you're doing 4 fractions, the easiest way is to do common denominator, and it's a lot easier to put them from in order from least to greatest. Okay, but I wanted to show you that. Okay, let's talk about student book. So on page 262, they're using the bar model again. Once again, they're showing you 2/3 can also be 4/6. And 2/3 can also be 6/9. Notice they're all the same. They're equivalent fractions. Okay, 2/3, 4/6, 6/9. They're all equivalent. Okay, you can kind of tell here we went from 3 pieces to 6. It doubled. Well, yeah, it doubled. We multiplied the top and the bottom by 2. Then down here, Mr. Bauer, the pieces tripled. Well, yeah, we multiplied by 3. 2 times 3 is 6, 3 times 3 is 9. Yeah, we tripled it. And then just to show you, you can do bigger numbers too. 2/3 times a 9/9 is 18/27. And I also wanted to put equals 2/3 because this is when we simplify fractions into their lowest terms, okay? Reducing fractions is another way of saying it, into lowest terms. 18/27 is also 2/3, just to keep that in mind. All right, so page 263 and 264, it's just making and comparing fractions. You know, you make, from the word problem, you make 2 fractions and then you say which one's bigger, smaller, blah, 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 okay? 265 is showing common denominator. I showed you several times here, common denominator. 266 and 267 is just more fraction work, kind of the same of what you've been doing. What I did want to show you is on 267, number 1B, okay? How many 6 are equal to 4/12? Okay? So you've taken 4/12, and what this means is that's the denominator. Okay? Now, if I told you whatever you do to the bottom, you have to do the same to the top, does that ring a bell? How does 12 go to 6? Okay? I know you're thinking, well, it cuts it in half. Yes, you're right, because we're dividing by 2. 12 divided by 2 is 6. So to get the equivalent fraction here of how many 6, we have to divide by 2 on the top, and that's 2. So yeah, 4/12 and 2/6 are equal, and they're also equal to 1/3 if we went all the way down to simplest form. 4/12 is 1/3, 2/6 is 1/3. Okay? Isn't that cool? All right. So, HC is just more fraction practice. I looked at it, I didn't see anything new. So your final here, this was kind of a long video, but student book 260 to 267, HC 135 and 136. And like I said, that should complete module 1 for unit 7. Okay? that was a lot into, what was that, 15 minutes or so?
20.
20 minutes. Woo!
Woo.
Okay, I've been talking too long for an old man. All right. So 4th grade, I hope this helps you get through the last part of Module 1. Okay? And just have a great day. And Studio B is out. See you later.